Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 28, 2025, just yesterday. The standout result is a 14 billion parameter math reasoner that reaches pass at one of 80.6% on AIME24 and 69.8% on AIME25, surpassing DeepSeek R1 at 671 billion parameters while generating shorter answers. The paper is titled rStar2-Agent, Agentic Reasoning Technical Report, and as we will see later, the implications for training efficiency are quite significant. Beyond scores, the model uses a Python tool environment plus a new GRPO-RoC method and a compact multi-stage recipe to learn robust, reflective reasoning. Also, the author shared the code on GitHub. You'll find a full rStar2-Agent implementation with examples for tool calling chat, evaluation scripts for AIM and Math500, RL training pipelines built on VERL and CodeJudge, data pre-processing utilities, install scripts, and a detailed README explaining setup, servers, and troubleshooting. On Hugging Face, you'll find rStar2-Agent 14 billion parameters, BF 16 weights, plus SG Lang server, and OpenAI API code snippets showing tool calling and Python execution for math reasoning tasks. Alright, the introduction highlighted those headline AIME gains and the agentic setup. Figure 1 shows the training curve that makes the claim concrete, with AIME24 accuracy on the vertical axis and RL training steps on the horizontal. The green series for rStar2-Agent 14 billion jumps rapidly to about 80.6% within roughly 510 steps, which signals very sample-efficient learning. The purple series for DeepSeek R10 at 671 billion climbs more slowly and levels near 71.0% after thousands of steps. Okay, the training curve just showed rapid gains with few steps. Table 1 now reports headline accuracy across AIME24, AIME25, and HMMT25. rStar2-Agent 14 billion leads AIME24 at 80.6%, and posts 69.8% on AIME25 and 52.7% on HMMT25, which places it alongside or above much larger systems. The comparison underscores efficiency because similarly strong scores come from a far smaller model and shorter responses. Well, Table 1 just underscored accuracy and efficiency. Figure 2 shows how multi-turn rollouts work in the Python environment, where chain of thought, tool use, and tool response alternate so that execution feedback shapes the next step. The top timeline depicts turns that include code calls and appended feedback, which culminate in an answer verify step. The lower example illustrates turns that call, execute Python code, parse results, and then confirm the final answer so the agent reasons, checks, and refines within the loop. So, the multi-turn timeline just clarified how execution feedback steers reasoning. Table 3 now compares models on Math500, AIME24, AIME25, and HMMT25, and it also shows which systems used reasoning SFT before reinforcement learning. The rStar2-Agent 14 billion row leads AIME24 at 80.6% and posts 69.8% on AIME25 and 52.7% on HMMT25, which matches or surpasses much larger models. The contrast matters because most baselines relied on reasoning SFT, while this system used only a lightweight, non-reasoning warm start. Wrapping up, 2 takeaways stand out. The 14 billion model delivers frontier accuracy with much shorter answers, and it achieves that through agentic reinforcement learning with Python tools plus GRPO-RoC, all trained in about a week on modest hardware. The broader implication is practical, affordable tool-grounded reasoning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.